All right, so I'm here to talk about change. And in this case, the new world of Android O, which isn't quite as new anymore. How many people here have actually played with Android O? I've put in, all right, that's great. And there are a lot of cool things in Android Oreo, but it really does change a few things for developers in a significant way, and particularly what you can and can't do with background work, and changes the way location gathering works when your app is in the background. And the way I'd like to start this is not by going immediately into those details, but here are things you should remember about Oreo. Reasons why you should do it: you have more control over the way your icons look in OEM launchers. We have notification channels or categories, depending on whether you're looking in the API or in the user interface. We have notification dots or badges, depending on whether you're looking in the API, in the user interface or in the API. We can pin shortcuts, which is pretty cool. You can actually have your app request to pin shortcuts. And my favorite thing that we've needed for so long is your app can actually finally request that its widget get pinned on the launcher. So like all these things that are really good, I think that we needed to do for a long time. One of my favorite features is picture-in-picture mode. This is Allo, but I think Google Maps might be my favorite. It's just so awesome when you're going and catching Pokemon and trying to figure out where to go, and you can have Pokemon. Oh, never mind. All right, and of course, we support multi-display for real. You can actually, user can actually launch an app on another display, which is cool. And I don't actually have a device where I can test this, but I'm sure it's really awesome. And we have extended aspect ratio screens. And this comes automatically as soon as you target O. But the good thing about O is you can actually change whether your app specifically supports it or not as well, which we didn't really have. We kind of had a way to do it in N, but there's actually a proper way to do it in O. And if you support resizable activity, it automatically assumes you support extended aspect ratio screens. So really, that's what you all should be doing. Of course, we've added autofill, which is great. No more hacks around accessibility to do this feature. You can actually have like real, platform-supported autofill, which is great. Make sure you put hints into your XML so that autofill does a good job. Font resources and downloadable fonts. This is actually my favorite feature. I'm sort of a font collector. I was going to say something a little bit more crass, but let's say collector. And it's just awesome to actually have Android have full font support, and also just the amount of work it takes to actually include a random font in your app is now so easy. You actually have real font resources. You just include them in XML. You say, I want to have this font in my text view, and it's just there, which is awesome. So for any of you who are just annoyed like me that you had to make your own extension of text view just to do fonts, this is really great. We have auto sizing, which is also like one of those features like, oh my God, how long have we been waiting for this? Like this is all stuff. And the best thing about fonts and text view auto sizing is they're in the support library, so you can use them all the way back to ICS. This is something a lot of people may not have noticed, but we actually added A-Audio, which is a high-performance audio SDK that's part of Android O. And very, very recently, like in the last week and a half or so, we've actually released a library called Oboe. And Oboe allows you to write to the new API and to OpenSL by targeting a C++ wrapper that looks a lot like the new API. And it's a lot easier to use. And it allows you to do things like target exclusive mode, which bypasses the system mixer to give you lower latency. And so this really gives you very, very professional audio quality. And exclusive mode has been enabled on Pixel and Pixel 2 in the developer preview. So if you have one of those and you want to play with it, you can try out the sample and you'd be like, wow, that's really, really low. That's really cool. So of course, we have the Neural Networks API. This was announced in Android 8.1. And this is not something we expect developers to directly target because there's going to be cool stuff like TensorFlow Lite layered on top of it, which will actually be what you use to execute these deep trained models. But it shows kind of the commitment we have to accelerating the ability for you guys to do the same stuff that we're already doing with machine intelligence and go way beyond the stuff we're doing, hopefully. Many of you might not have noticed this, but there's actually now a real shared memory API in Android 8.1, which is kind of cool. And this allows you to actually simply say, it creates an object which can be parcelable, which you can send to another process. So if you're building an app that has multiple processes in it, this is really, really nice. Before this, there really wasn't a good way to share memory. You could use the memory map file stuff that we had, but this is actually a way to have real blocks of memory with memory protection. You can actually share it within your own app, or you can share it to another app. And there's an NDK API, so if you want to share memory and have it being read directly by the NDK, you can do that too. So just a lot of stuff that's really cool, and there's just tons more stuff in O. I'm not going to go through that because that's actually not what this talk is about. This talk is about all the stuff that's actually changing. And the reason I highlighted that is there's a lot of good stuff in O that you probably want to take advantage of. Now here's something many people may not know about me. I do ballroom dance. I've been doing it for about 20 years, and ballroom dance works because the participants all agree to dance in a somewhat choreographed fashion. You know, it's all about we're all going the same direction, and as one person leaves their space on the floor, the next person comes and joins that space, and we're all dancing really fast, and we're all getting what we want to get done, but we're not getting in each other's way. And if we were to do a bunch of Android apps trying to do the same kind of dance, it would look sort of like this. And the reason why is that there isn't really a good way to coordinate what's going on, and this is what really things were like pre-O. So to help choreograph the way apps work together a bit better, Android Oreo adds background and location limits. And these are big changes for app developers, and I really don't want to say anything other than just don't panic yet. Because change isn't always bad. And having apps share system resources better is good for everyone, both our users and I think ultimately for developers as well. Now, of course, not everyone is happy with change. So we published kind of our first YouTube video about this. We got some great comments back, like, you know, holy, you guys don't miss any chance to the developers over, or, you know, background services are not allowed to be run in the background. You know, wake locks will still be taken away if the system decides to. You know, you guys just want to every developer and feel smart about it, okay? These, you know, and I understand what makes me happy about this is to see how passionate people are about the things that we do. I was a little sad by the last one. I just paid for an Android N course. I'm just like, oh, I'm sorry. It really hasn't changed that much. But to me, that's, as much as I think maybe we could be a little bit more refined in our discourse, I think that, that it's great to see that people really do care, and we really do care as well. And really what it comes down to is that we've been making changes for a long time, especially the last several releases, to target improvements in system health, primarily RAM we're talking about, in battery. And we really aren't trying to ruin your apps. We're really not trying to make your lives needlessly harder. But what we're trying to do is make sure that our users get really fluid multitasking, and more importantly, that they don't shy away from installing apps. Like, the worst thing that can happen is if someone gets their phone, they're like, oh, this thing's pretty awesome. Look at how smooth it is and how great it, how long the battery lasts. And then they install 150 apps, and all of a sudden they're like, wow, this thing is terrible. It's like it's slow, and I don't know what happened, but they just put something into the system that makes it slower the longer I own it. And they're sending secret updates or something like that. I'm like, no, it's because ultimately, we all have to work together to make this a great experience. We want to make sure we give you guys the best tools for that. So we've really been doing this for a long time. And if you saw the marvelous history talk that was given in the keynote by Chet and Roman, you see there's actually been a long road to get to where we are now. But for me, it really started with Android E. That was actually when I joined Google. And it also starts this journey about notifications and the way we've been affecting developers, because we used to, prior to Android E, Eclair, we actually allowed you to start Foreground Services and you didn't need to supply a notification. And we noticed that a lot of apps were just like, well, we're just going to run all the time. We don't have to, if the user doesn't know we're doing it, might as well just have the highest priority thing we can. So we did this, and developers quickly realized they could put a null in and they could keep doing it. So it wasn't for several releases where all of a sudden you noticed, oh my God, there's like 5 notifications showing up for this app. And developers then actually started posting notifications and using things well. But this was like the beginning of it. So to think we just started doing this has been done for a while. In Android K, we actually made it, and this is, I think the alarm manager API is unfortunately one of the more warped things that we ended up out of this, because we now have like, what exactly is an exact alarm versus an inexact alarm. So, but if you use a regular alarm, now it's an inexact alarm, and then there's another set of alarms that's more exact, and then there's real time now because of doze. And of course we had a doze in Android M. And this is important because we have something that actually gives people long idle battery life. And it's, like once we put doze in, my tablet went from having like a day and a half of idle time to having a week and a half of idle time. And that's kind of cool. I'm not constantly panicked that I'm not charging it. And this is triggered, of course, when the device is not charging, and the screen is off, and the device is stationary, and it basically creates this whole maintenance window thing. And this was a big change, because for the most part, Android has really, really tried hard not to do behavior changes, and all of a sudden now we're starting to add it. So this is a pretty big deal. And of course, we added app standby, and this means that if your app hasn't been interacted with in a long time, it defers its background activity also. So it's again, if a user installs a lot of apps, this is a way of keeping them happy while still allowing them to have a ton of apps on their device. And then in Android N, we added this kind of doze light mode that also works when the device isn't stationary, but you're not using it. And again, this is important stuff. It's all leading up to where we are now. Also, we have problematic broadcasts, and this is like one of the most critical things that we did. So, people would have their app get started every time network change happened. And you can imagine what that looks like to the system. It basically, every single time a network change happened, every time someone shot a photo, all of these apps would wake up and be like, oh, should I do something now? And of course, that means all their processes are all getting loaded into memory. Their Java classes are all getting loaded by the runtime. All of these things, all this craziness is going on. And of course, it means that the phone just isn't as smooth as it should be. So connectivity action was limited in N. Action new picture and action new video were limited in N. And this makes sense. You can still register them with register receiver if you're actually running. But if you're not running, then you can't get access and your app won't get launched, which is important because launching your app is expensive. So that gets us to here. No starting services in the background. And a lot of people are like, well, wait, what are services for if you can't start them in the background? And I've definitely gotten this question. And so first of all, you can still start them in the foreground. That's just fine. Another thing, of course, is we also increased the limits on implicit broadcasts in the manifest. And again, this is only when apps target O. Another thing we did was actually address some other system health problems, and this is more battery than anything else. We saw that a lot of apps were just constantly doing location queries in the background and waking up the CPU and waking up the radio and all of those sorts of things that happen when you do a location query, and that's just not very cool. Because it just guarantees you're going to have really, really terrible battery life. So for every single app running on O, whether you're targeting or not, if you're trying to do background location, we'll actually be throttling that. And I'll kind of get into a little detail about that. And again, the path to this was because battery life is a huge problem with a big font. And 1 of 3 users actually tell us that battery life is their biggest problem. And so what they do is they figured out, aha, location is actually the culprit, and they turn off location, and then no apps get the benefit of location. We see this happening all over the time, all over the place. So this wasn't just hurting people installing apps, this was hurting every developer, because now instead of getting a slightly limited location, they're not getting any location at all. And we really want to encourage our users to actually keep it on, because there's a lot of apps that are great with location, and it means a world of difference to have it be enabled. All right, so what does this mean, foreground versus background? You guys all know this, and it's pretty straightforward mostly. Your foreground, if you've got a foreground component like that, your background if you don't, sort of. If you're a foreground service, you're also foreground. So that means you've got a notification sitting up there. And there's no limit on these in O, so if you need to use a foreground service, to get your work done, that's great. If you have a bound service, and the client that's bound to you is visible, then you also are in the foreground. And same thing that happens if you have a content provider. So if someone else is accessing your content provider, you are therefore in the foreground. And there's also a few other weird cases that are really important because your apps probably wouldn't work. If you're an app accessibility service, an OK notification listener service, abstract account authenticator, or live wallpaper, you got to be in the foreground, considered in the foreground, and nothing changes. So under all those circumstances, it's just as normal. Now, of course, again, if you're not visible, these are when you're in the background. Typically, if you're in a started service that's not in the foreground, you're in the background. If you're running in a job service. And of course, if you have a broadcast receiver get called, again, you're running in the background. In this case, all the background limits apply. So the overriding principle of this, of course, is if your app is doing a whole bunch of stuff in the background, users should have some visibility into it. And I think we're still trying to figure out exactly how much visibility into it and how to actually telegraph that the right way. But that's really been our goal for a very long time. You can see all the way back in Eclair, we kind of started this principle, and we're continuing to work on that and to iterate on that to make this actually better for users. And so if you actually try to start a service from the background, you get an illegal state exception. And one of the things that came to mind is, why didn't we just limit what services could do? And a lot of this has to do with, like, once again, making behavior changes is dangerous. This isn't really a behavior change to the whole way services function. Your service either starts or doesn't. Your app very quickly fails. That's a much better circumstance than, well, my service just wasn't able to run as long as it used to, and my app kind of worked in most cases but didn't work in others. This makes it really clear what's going to go on, what's happening. Your service just doesn't run. And it doesn't matter, again, whether the caller of start service is in the foreground. It only matters whether the app that's actually hosting the service is in the foreground. So for example, if you send a pending intent off to an app that is in the foreground, and that foreground app tries to use that pending intent to start your app, it will not work. So for all intents and purposes, most of the time, just don't use services in a pending intent and passing it to another app, because it just most of the time isn't going to work these days. And then once services have been launched in the foreground, it continues to run in the background, even if your app is no longer in the foreground, for a limited duration. And it's not really clear what that duration is, but note that it is, in computer science terms, it is long. We're not talking about even seconds here. We're talking about a substantial amount of time to get work done. So it's not that the services that are launched in the background are useless. They're actually quite useful when launched from the foreground, especially since, as I sort of alluded to before, one of the things we changed is if you hold a wake lock and you no longer have any active components, that wake lock will get canceled. So it's kind of important to tell the system that you still are doing something, particularly And again, there are also times when your app is temporarily whitelisted to launch background services. And so for example, high priority cloud message, SMS or MMS delivery notification actions. This is kind of cool. So actually, you can use pending intent in notifications, which is kind of good. That was a change that I pushed through. And there are no restrictions at all on foreground services once again, because they have a notification. That's the way things are supposed to be, and users can tell they're running. In order to avoid that illegal state exception we mentioned earlier, because we want the API to fail quickly for developers so there's no question as to what's going on, we actually added this API that called Start Foreground Service. Now this doesn't actually make the service foreground. It just tells the system that this service is planning to become foreground. It'll allow it to run for a couple of seconds as a service, and then if you don't actually promote it to being a foreground service, it will die. So you still have to treat it only thing that can actually promote a service to the foreground is the service itself. This just tells the operating system, I'm planning to do that, and so you can, again, launch it. And there is no API to figure out when it is safe to call start service. So you have to do this through design of your app, basically. Binding to services, again, it's not changed. So as I mentioned before, there's no changes or limitations on the ability to bind to services. It automatically lifts the service up if you bind to a background service while you are in the foreground, all of that sort of thing. And of course, intent services are services too. It doesn't mean you should or shouldn't use them. You just have to think about it. But what we did do is actually create this weird thing called job intent service, which is in the support library. And what that does is it actually says, all right, if you're on previous to Android O, we'll actually launch a regular old intent service. If you're on Android O, what we'll do is we'll actually start a job. And that, just to make it easier, it's a little weird because you have to have like slightly different stuff in your manifest, but it's pretty straightforward, and it's just one nice way of being, okay, if you want like a little handhold to get into the new world, it does it for you, and it's also compatible. So like you don't have to worry about, okay, I'm on an old version of Android that doesn't have job service, or a version where it might be broken. I can just use that freely. And that brings us, of course, to Job Scheduler. And the intent, of course, is that most applications are going to move to Job Scheduler or Firebase Job Dispatcher or some other library that wraps them for executing background work, which allows the platform to schedule things in an efficient way. And of course, Android N had a few broadcasts that are no longer allowed to wake up apps, but Android O basically has most implicit broadcasts are not going to be delivered to manifest-derived receivers, basically. And there are some exceptions, quid pro quo, all these sorts of things. We have action package replaced actually will not be seen, but action my package replaced will, for those people who absolutely need to use this. But again, in many cases, some of the most critical broadcasts can be replaced by things like a job scheduler job with appropriate constraints. Again, we do have a bunch of other exceptions that are important to note. Boot completed, so you can still re-register those alarms if you need them, or if you need to register a job service that triggers off of a content provider change. You can still do that in boot completed. And then we've got a couple things that are sent infrequently that might be useful, like locale change and headset plug and SMS received action. So those still work as normal. There are just a few exceptions there. And again, these only apply to things that are registered in the manifest. So if you use register receiver, it's fine. It'll always work in your app. It's just talking about stuff in the manifest. All right, so what do you need to do by this? I mean, again, we've talked a lot about users, but so first of all, obviously, Firebase Cloud Messaging is another interesting one. If you use a high priority message, you can actually launch a background service because it actually these things are all actually tied together. So as it turns out, anything that also is exempt to DOS, like a high priority message, is also exempt for background service limitations. So you can go free, your code can work exactly how it worked before, and that's cool. Normal priority message, like before, lets the OS schedule. You cannot launch a background service from a normal priority message again. And don't abuse this. Don't make all of your messages high priority all of a sudden, because again, that wakes the device up from doze, and that means the battery's going to run out faster when it's idling, and that's really bad all around because it means that people are going to be mad about their devices not having battery. Job intent service, as I mentioned before, is in the support library. It uses job scheduler and queue on O+, and it uses context start service prio. Understands backhaul service. Another thing that kind of doesn't make any sense in this world is the wakeful broadcast receiver, which of course was used to start a service and do a wake lock and kind of handle everything for you. But since background services no longer work the way they used to, for the most part, this API doesn't make any sense anymore. So that's deprecated. And again, the real way to do everything is with jobs. So think about what. So now you're like, well, maybe I'll just switch everything to foreground services. And really it comes down to what will the user approve of. And obviously things that are ongoing tasks, things that like, I'm running, I've got some sort of navigation going on, I'm playing music. Obviously the user approves of these things. The user needs, those things need to keep running. They have a UI. Many of them have an interactive UI of some sort, which is great within the notification tray. So those are also all kind of awesome stuff. And it really comes down to, do you actually need to run a foreground service? Because the worst thing that could possibly happen is we've done all of this work and everyone goes, well, we're just going to run a foreground service. And that would like go against everything that we've been trying to do. And the framework engineers are going to have to scratch their head and go, all right, well, how do we stop this from happening? And realistically, I don't want to give them any more work. I want to get all the cool features they're trying to put into P rather than try to figure out how to work around the fact that developers are working around this. So in general, unless you really need to do a foreground service, please don't. All right, Location limits, I mentioned this a little earlier. 1 in 3 users, again, tell us battery is their main concern, and they disable location, which is terrible. So even when your app is in the foreground, location gathering remains unchanged. When you go in the background, it starts throttling, even if your location request is something faster. And this is a little vague intentionally because we're still tweaking it. And because this works on a device-wide basis, this happens regardless of what version you target. So this is like DOS. And one way you could do is to use batching, which gives up some latency, but you get more data points. Wi-Fi scans are efficient. So once again, we're doing some smart stuff here. If your device stays connected to the same static access point, we do not actually do a lot of location, which is kind of cool. And this helps when a user is at work or home. I don't know what happens around a bus that has Wi-Fi, so I'm kind of curious. Another thing to think about is geofencing. We are a little bit smarter about it now. We've changed the responsiveness, but it does make it a lot more efficient. And another thing to think about is, again, pending intents really can't be used with location anymore because they start a background service. So instead of using get service, use pending intent dot get broadcast. And you can use that everywhere, and it actually works really well for most cases. A lot of people use a service when they don't have to because you can do start async and pending intents and usually get what you need to get done. All right, so if you have really aggressive needs for location, one, again, geofencing is great. It should be part of your strategy. It's cool because we can really optimize this around performance. We can think about cells and make sure we're using the most efficient API, and that's important. Now, let's say you want to, you can only have about 100 geofences. So let's say you have thousands of stores or something like that spread out over a wide geographic area. You can actually be smart about it. So you can actually create these like geofence areas, and as you move in and out of them, you can substitute different geofences, and that works pretty well. So just because there is some limit here doesn't mean that you can't actually still use this. There's lots of clever strategies to still maintain reasonable battery life and take advantage of, like, when someone walks into your storefront, notifying them that they're there and doing something cool. Another thing, of course, you can do is using beacons, because if you've got some storefront that has ridiculous numbers of locations, geofencing isn't going to be a good idea either, because it's just going to mean location services are always on whenever you're anywhere, if you're like a certain prolific coffee vendor. And again, using batching is great. So you trade up you get a whole bunch of collection, but you're not constantly being notified of it, which is awesome. You should do that anyways. And here's some fun. So once again, you can set batching up pretty easily. When you're creating your request, you set the update interval using set interval, and if you can set a longer interval using max wait time, and locations will then be delivered in batches, which is kind of cool. So this example has location being calculated every 10 minutes, more or less, but delivered every 30 minutes, more or less. So basically, you'll get 3 data points rather than 1, and for background usage, this may be enough data for some kinds of apps. Another thing to do, of course, is get location passively. So this is kind of cool. So when another app is in the foreground and they're actually using location, we've talked about this for a long time. I think Reto said this at Google I/O like 3 or 4 years ago, but it's always worth repeating. You can get what they call a passive location listener. And the question is, should you always use this set fastest interval to do that? And for the most part, it's not a bad thing. I mean, if you don't need it, don't do it. But it's pretty low cost to be a passive listener, and you just set that. So here's some more fun there for location, and it's a really good strategy if you're just trying to gather data. All right. So the real question is, because you have to actually, do this to make things work well on O, and people who are, important in the sense that they're early influencers and adopters and all that will be having O, it's a good thing to think about this now and make sure your apps actually do these location strategies. And again, it just helps everything all around. Again, so reducing the frequency, increasing the latency, all of these things, and also rethinking accuracy. Well, how much location accuracy do you really need? Do you really need high accuracy, or is it good enough for you to get kind of zones of where the user is? And all this is really important when you're thinking about how your app is affecting the system health. And that's really what we're all about here in Android O and all of these changes we made. So again, and if you absolutely need it, if you use a foreground service, And there are some cases in which that's going to be the only option for location. But for the most part, I think what we've seen is that actually with the limits we have, almost every use case works extremely, extremely well. And if you have a use case where you're like, I don't think a foreground service makes sense, but on the other hand, I don't think there's a way to do it, my suggestion is this is a good time to file an issue with the issue tracker and say, look, my use case does not work with Android O. You guys should fix it. And if it's an important enough use case that we see a lot of that actually this is the kind of thing we do. So again, if you're like my life is over, my app will never work again unless I use a foreground service. And this is something compelling that a lot of developers need and a lot of users will benefit from. Let us know, because we can still change the world. So if there's anything I want to say is that change actually can be good, because this is a really tough balance. But these changes allow apps to have more predictable performance, and this makes it harder for a new app to negatively impact the tasks that users rely on most, as well as their battery life, while giving apps the power they need to meet user needs, which is important. Or if going back to my original example here, these new changes give Android Oreo the superpower to choreograph apps to balance system health, battery usage, and more. And the biggest thing that has to happen now is that more and more apps have to target O. Because otherwise, we're still stuck in a world where apps are running, the choreography is hard. But as we actually see more and more apps targeting O, we're going to see better performance, better battery life, and hopefully a smoother experience for our users. And that's really the important thing I wanted to leave with here. Of course, you can find all about O here. If you want to see that Oboe API and play with it, you can go to the GitHub side for Google Samples, and it is sitting right there as an open source project for you to play with. And thank you very much. I'm here to take questions, and I really appreciate you spending the very end of your day here at DroidCon over with me. So thank you. I don't think anyone completely, well, maybe a little bit of somnolence happened. So any questions? So the question is, if you're looking at an app and you see the manifest has a service in it, does that mean, is that a red flag? Is that the kind of thing we'd have to re-architect? And it really depends how it's used. I mean, a lot of apps use a service to indicate to the operating system that they're going to run something a little bit beyond the foreground. It's certainly worth looking into. But for example, a lot of people use intent services, and a lot of times those only get started from the foreground. Certainly, that's kind of the use case that I've been promoting for a long time, is to only use them for services that are launched from the foreground. So in that case, it probably doesn't matter, but you'll have to look at each individual one. It's certainly not a bad thing to look at the manifest and look at all the services and say, do all these really need to be services? Maybe some of them should be broadcast receivers. And that's the kind of the easy fix. Is there are so many times when people actually use a service where they actually could use a broadcast receiver with Go Async, and so that's usually a really trivial fix if that's what you can do. So again, if it has to run for a really long time, then you need to go to jobs. But in a lot of cases, a lot of these things actually work really well with broadcast receivers. Yes. Oh, Bluetooth LE. Bluetooth LE. I mean, it's better than keeping a persistent connection. So the answer to the question was, does Bluetooth LE really help save the battery? And it's a lot better than keeping a persistent Bluetooth connection open to a device. A lot of it also depends on how you're using Bluetooth. If you're sending large streams of data, then actually LE really doesn't help very much with that. But what LE is great, what Bluetooth LE, Bluetooth Smart is great at, if you're getting little packets every once in a while from a device, very sparse usage of the API, then Bluetooth LE gives you huge power savings. Actually, it's also really good for latency. It's kind of this shocking thing. It's not great for throughput, but it's really, really good for latency, and it's really, really good for battery life with short, small bursts. So, anything else? All right. Well, in that case, again, thank you all for coming, and enjoy the rest of your DroidCon.